So, my dear students, now we are going to look at a carry look ahead adder. In carry look ahead adder, what exactly that we are trying to do is we are trying to calculate carry, okay, in order to compute the addition. So, in what way it is different from parallel adder is in parallel adder, carry is going to ripple carry. Carry has to move from one stage to other stage, one stage to other stage. Okay. So, to avoid it, what we can do is we can use carry look ahead adder. So from each stage, if there is certain delay d, for n is equals to 128 adder, okay, accordingly it will be 127 times of ripple carry plus one delay of sum calculation, so that your final sum will be available. So this is what exactly the issue that we have studied already in case of parallel adder. So to avoid this problem, what exactly that I am trying to do is we are trying to work on full adder, which is a plus b plus c in, and we try to see full adder functionality in a different perspective. What is that is something like this. This is exactly the full adder truth table which we know. These are the set of inputs we have. These are the outputs which we know already with respect to full adder we have seen. Now in this, what exactly that we are trying to do is would like to compare it. What exactly that I am trying to compare is I'll compare C out and C in. What exactly that I am trying to do is comparing C out with C in. So, if at all you look at this C in is compared with C out. Based on that, I am trying to write propagate, generate and kill. P stands for propagate. That means you are sending propagate. Okay. G stands for generate. Okay. K stands for kill. Now let's see what it is. When A, B are 0, 0, okay, when AB is 0, 1, when AB is 1, 0, when AB is 1, 1. I have divided the all possible 8 cases into 4 segments. When AB is 0, 0, when input is 0 and 0, your carry out is always 0, doesn't depend on carry in, which means it is killing the carry. Killing the carry means K is equals to 1. Right? For the rest of the things, there is no carry being 0, so there is no more kill. So no more kill, then no more kill. I am defining a new function based on input carry and output carry with respect to full adder. Now if you look at here, this is 0, 1, whereas this is always 0. Always 0 is called kill. But if you look at here next, if you compare carry in for 0, 1 and 1, 0, whatever the carry in is there, the same thing is there at the carry out, as if it is propagated to out. In becomes out. So carry out is nothing but carry in. That is called propagate. So propagate I am putting as 1 because for these cases it is 1. For the rest of the cases there is no such thing called carry in is equal to carry out. Now you can understand why the name propagate. Okay, the name propagate is introduced here because your carry out is nothing but carry in. You need not calculate the carry out, just you send it. That sending the carry in as carry out is called propagate. Right? So now you look at the other case, that is when this is when A, B are 1, 1. When AB is 0, 1 and 1, 0 cases, this is what exactly happening. Carry out is equal to carry in. For this case, if at all you look at. Carry in is 0, 1. Of course, it is changing, but carry out is fixed. Fixed and it is being 1. So as it is generated, I need to generate. I need not look at C in. So C out is equal to 1. C out may be equal to 0. C out is nothing but C in. So in general, what I can say is whatever the carry out that I am interested in carry out. So carry out may be 0, may be 1. So I can force output carry to 0. I can force output carry to 1. I am forcing output carry to 0. I am forcing output carry to 1. Or I can send C in as carry out. So what is the meaning of that is when I don't know the carry out, the possibilities are something like this. Carry out can be 1, carry out can be 0, carry out can be C in. If carry out is 0, force it to be 0, then we are calling it as kill. If it is 1, it is called generate. If it is seen, it is called propagate. When it happens, kill happens when A equal to 0, B equal to 0. Propagate happens when A0, B1 or A1, B0. Generate happens when A equal to 1, B equal to 1. Okay. Now if you look at this propagate, okay, if we use it in the KMap, when 0 1 or 1 0 it is 1, for rest of the cases it is 0. Okay, so what is that one? Say for example I have a, b and y, 0 0 0 1 1 0 1 1. For 1 1 the output is 0, for 0 0 output is 0, for 0 1 or 1 0 output is 1, which is nothing but XOR operation. So this propagate is nothing but A XOR B. Generate operation is nothing but when is generate is happening when A equal to 1, B equal to 1. So A1, B1. Generate is AB. So what exactly that I have introduced from this analysis is what is propagate is A XOR B. What is generate is A and B. So what exactly that I am trying to do now is very simple, that this is what exactly happens with respect to full adder. Now look at the full adder using half adders. I have a half adder. What is that half adder? A XOR B. You take both the inputs, then you AND it, then you take another input which is C in. From there you connect it to XOR gate. Next what you need to do? You take these two, AND them, you'll get the output. That and this you try to OR it, you are going to get your carry out. This is what exactly? A XOR B. This is AB, right? This is your sum. The sum is A XOR B XOR C in. What about this? Is I know that P, this is P. What I know is this is G. Okay. This is with respect to one full adder, right? So what about this one? This is nothing but P. This is nothing but C in. So can I say P C in? Right? And what about this? This is G. So what is carry out here? Carry out can be written as G plus P C in. Okay. This is with respect to one full adder. When we are working with couple of full adders, what I can say? Let's say I is a stage 0, stage 1, stage 2, stage 3. So what I try to do is I introduce a new index value I, which varies from 0 to some value n. Okay, so I is index value which refers to different full adders, right? So what I try to do is, instead of saying A and B, I say AI and BI. So I am showing a typical stage wherein we will be having the CI as input. Okay, this is AI BI, AI XR BI, this is PI. Okay, so this is your sum stage I. This is carry out. Carry out becomes CI plus 1. This is PI. Okay. Only thing is, just we are generalizing the things. What I have written for with respect to one full adder, I am converting into any full adder of interest. This will be GI. This is GI. Right. So from this, what is clear is, we will try to write the expression, and from that we try to see how exactly we are making the calculations. So what is that? That is, there is C output becomes Ci plus 1. Output becomes I plus 1. What is I plus 1 is Gi, Pi. This instead of in, it becomes I. So this is nothing but Ci plus 1. So I write like this. Ci plus 1 is nothing but Gi, Pi, then Ci. Okay. So what I can do now is, if you want, say for example, if I want I equal to 0, let's say I equal to 0. So C1 is nothing but Z0, P0 and C0. C0 is nothing but C in. Next, if you want C2, what is C2? C2 is C1 plus 1. So this is G1, right, plus P1, C1. What is C1? I know from this C1. Let's say this equation number 1. So this equation number 2. You use 1 in 2. Use 1 in 2. What is going to happen is, C2 is nothing but Z1 plus P1. What is C1? C1 is Z0 plus P0 Cn. So if you expand this, C2 is nothing but Z1 plus P1 G0 P1 P0 Cn. Right? So further what I can do is, if you want C3, what is C3? C3 is nothing but from this expression, when I equal to 2. G2 plus P2 then C2. Okay, this is nothing but C of 2 plus 1 is C3. So what is G2? I will write as it is. P2, I know C2 from here, from equation number 3. So C2 is what exactly? G1 P1 G0 P1 P0 Cn. So if you multiply it, C3 becomes G2 P2 G1 P2 P1 G0 then P2 P1 P0 into C. Okay. So similarly I can go for C4. So on and so forth. What is the beauty of this expression is, if you look at C1, which is function of Cin, if we look at C2, which is also function of Cin, if you look at the expressions, it depends on generate, depends on generates, propagates, seen. Similarly, generate, propagate, seen. Okay. Where similarly C3, which depends on, which is a function of generate, propagate, seen. But in case of parallel adder, this is not the case. If you want C3, okay, you have to compute C0, C1, C2. If you want C4, you have to compute C0, C1, C2, C3. If you want C5, say C5, you have to compute C0, C1, C2, C3, C4. But here it is depending on only Cn. So what we are doing is, before making the calculations of sum, we are computing the carry from generate, propagate and Cn. What is generate is A, I, Bi, Gi, Pi, Ci. What is propagate is Ai XORed with Bi. So from the XOR and AND operations, we are getting generated propagates. From generates and propagates and Cn, okay, we are able to calculate carry of interest. C carry, say maybe C4 or C5 or C3 or C2, we do compute from the above expressions. So we never, if at all I want C5, I never depend on computation of C0, C1, C2, C3, C4. Instead, I use the expression for C5, then I can compute the value in order to compute the sum. Okay, how do you get the sum? The sum, if at all you look for, what exactly the sum? Sum is this, as I is nothing but Pi XORed with Ci. Why Pi? These two considered as Pi, Ci. So once I know the carry, once I know any carry of my interest, if you want sum is nothing but Pi XORed with Ci. So if you know C5 and P5, I can get sum. So this is how, without depending on the previous carries to be calculated, directly I can calculate the carry from the data of generate, propagate and carry in. I can get that particular carry. Once I know the propagates, okay, if I know the carry in to that particular stage without depending on carry to ripple, I can calculate my sum. This way of calculating the sum without depending on the previous carries, okay, directly from C in and generates and propagates, I am exactly getting my carry. From that I am getting sum. This way of calculation is known as carry look ahead adder. Okay, this way of getting the carry is carry look ahead carry generation. Okay, so this is what exactly carry look ahead adder.